All right, this is chapter 4, section 1, number 57. This one is the calculus part's easy. It's the algebra and trig part that's going to throw some of you off. So let's do this. On 57, what are they asking for? Let me read the instructions. They're asking for critical points and absolute extreme values. Now, you'll also notice there's a blue T next to this question. It means they want you to use your calculator. You need to start practicing using your calculator. I'm going to make a video on how do you use your calculator, but you need to start practicing because it's a skill you need to have. Half your AP tests will require a calculator. All right, so what are critical points? They are values of x where the derivative is 0 or does not exist. Notice we have a product rule, so we need to use, or we have a product, we have to use a product rule. So we're going to leave the first alone and take the derivative of the second. We're going to take the derivative of the first, but 2 to the x is exponential function. So I am my own grandpa times the ln of the base, and then I leave the second one alone, and I set that equal to 0 to find my critical points. Well, I have a common factor of 2x. I'm going to take that out, and I'll be left with cos x plus ln of 2 sine x. Now, to make this equal to 0, I set each factor equal to 0. Now, here's the part where your algebra skills need to come into play. This is something you need to know for the AP test. When is this equal to 0? Well, you should quickly get that because you should know the graph of the ln. Graph of exponential. It's like e to the x, but a different shape because it's a different base. Here's a question. When does this touch, wrong color, when does this touch the x-axis? It never touches the x-axis. Therefore, it never equals 0. So this has no solution. So you should know an exponential function never equals 0, unless it's been shifted up or down, but just the basic one won't. Okay, this is where your trig skills come into play. How do you solve the one on the right? Well, I'm going to subtract cos x from both sides. And I'm going to get this, ln 2 sine x equals the opposite of cos x. Here's where the trig trick comes into play. If you divide both sides by cos x, something beautiful happens. This becomes tangent. Now we have a situation where we have only one trig function instead of 2, and it becomes nice. We're going to divide both sides by ln of 2. And we have tan x equals -1 over ln of 2. But how do you get rid of a tan? All of you should know sunscreen. Don't your parents always make you use sunscreen? So we're going to sunscreen both sides. Inverse tan is sunscreen. It gets rid of a tan. So those cancel out, leaving x. And this is where your fancy calculator is going to go to work, because I can't do that in my head. If you can do that in your head, you are a genius. I'm going to cheat and look instead of putting this in my calculator. This comes out to be about -0.965. Now, here are the implications. Look at our domain. Our domain is from -2 to 6. I need to find all critical points in that region. Here is where understanding unit circle comes into play. So let's learn about the unit circle. Over here, this is pi or -pi, depending on which way you go. If you go this direction, positive pi. If you go this direction, negative pi. And pi is about 3. And that's about -1. So -1 is about 1/3 the way. Okay, so that actually, this is where your angle is -0.965. Here's where the unit circle comes into play. You should know from unit circle that That wasn't supposed to happen. Let me try that again. Wait, why isn't that erasing? Okay, there we go. You should know that opposite 180 degrees away, the tangent's exactly the same in the second and fourth quadrant. Okay, so this is where x is negative 0.965 plus pi. Why plus pi? Because from here to here, we added pi. Half a circle is pi. And then if we go again, another pi, this point here also is negative 0.965 plus 2 pi. Because I went pi and pi again. Why am I getting all of these? Because my domain goes from -2 to 6. Well, that's about -1. I can't go backwards -3 again, because that will put me at -4. That's out of my domain. But from -1, if I add 3, that puts me at about 2, which is less than 6. I add 3, that puts me at about 5, which is less than 6. So I actually end up with 3 critical points. So this arctan has multiple solutions. Negative 0.965 plus pi, and another one, negative 0.965 plus 2 pi. And we could keep adding pi's because we're at the same place, but we have to stop at 6. We can't go past 6. So we actually have 3 critical points. These 3. And now, ooh, I left them up here. I should have erased these. I'm going to just leave them up there. Save some time. So you should know max and min values of a continuous function on a closed interval occur at critical points and endpoints. You shouldn't memorize that. You should be able to visualize that. Go back to the video I did and make sure you understand why. That's a great quiz question, by the way. Where do max and mins occur on a closed interval? Continuous function on a closed interval? At endpoints and critical points. Well, -2 is an endpoint. 6 is an endpoint. These 3 are the 3 critical points we found. It seems very logical if I find the y value, the biggest y value would be the max, and the smallest y value is the min. So if you plug all of these values into this equation, these are the approximate y values you get. Now, some people get confused. Do I plug it into the derivative? Do I plug it into the function? Well, if you plug it into the derivative, does that get you y value? No, it gives you slope of the tangent line. The original function gets you y value. So once you do that, you get these 5 values that I have written down here. Which one's the biggest? Looks like that is the biggest value, so that's the maximum value. And which one's the smallest? To me, it looks like that is the smallest value. That's the minimum value, right? So that's how you find max and min. You find critical points, and then you find the y value at critical points, endpoints. Biggest one's max, smallest one's min, also known as extrema, also known as absolute max and absolute min, and also known as absolute extrema. So what am I going to do? I'm going to graph these. If you're not graphing these, shame on you. It's asking you to graph, and when you graph, it gives you a greater understanding. So I'm going to stop sharing the screen, and then I'm going to go to Desmos on my computer. And then I will show you this. Now I need to change this because it's 2x to the x sine x. So let me to the x sine x. And my domain is from -2 all the way up to 6. And I don't know if I graphed the right one, did I? Let me do some stuff here. Okay, there it is. Let me bring that bottom up a little bit. Let me go to bottom to -25. No, -40. There you go. There we go. So that is the graph of the function, but look, here's the endpoint and here's the endpoint. We found those values. We had 3 critical points. Right there, somewhere around there, yeah, the derivative at that point is 0. That's our negative 0.965. That's our first inverse tan that we found. We add pi, we got this point. We added pi again, we got this point. So we ended up with 3 points where the slope of the tangent line was 0, there, and there, that matches. And then the maximum occurred at the second one, and the minimum occurred at the third one. So that's how you do that problem.